Hello and welcome to another episode of How I Like Maths, which is all about how maths is used in real life. My name is Nahid. I'm the host of the show. I'm also an applied mathematician. I did a PhD in it. I'm also the founder of Bungee Pie, which helps children learn maths using storytelling, animations, and real-life applications. How I Like Maths is my own initiative to introduce you to great minds in the space of maths and its applications. Today I have a great speaker who is also an old friend of mine, Dr. Pooyan Jamshidi. Pooyan is an assistant professor in computer science and engineering at the University of South Carolina and visiting researcher at Google. He is the director of Artificial Intelligence and Systems Lab, where he and his students and postdocs design novel artificial intelligence and machine learning algorithms and investigate their theoretical guarantees. He is also interested in applying machine learning and AI algorithms in high-impact applications, including robotics, computer science, healthcare, neuroscience, space exploration, engineering, and science. Recently, he was awarded $1.2 million from National Science Foundations for his breakthrough ideas in artificial intelligence. Prior to his current position, Pooyan was a research associate at Carnegie Mellon University, US, and Imperial College London, UK. He received a PhD in computer science, a master's degree in system engineering, and a bachelor in applied mathematics. In this episode, he will talk about his work and its impact and what made it worth $1.2 million. Before listening to our conversation, I would like to ask you to subscribe to our platform and support us to continue this great work. It's absolutely my honor to have you on my podcast. How I Like Maths. It's always very interesting for me to see how far my friends go in life and what they achieve. What kind of life experience is fascinating, isn't it?
Yeah,
I still remember. It's unbelievable. Yeah, I know. I still remember those old days when we were too young and doing bachelor in applied maths. Funny, you were so famous for your loud laugh. I guess you were still.
Yeah, I know.
Yeah, I was quite famous for my laugh as well, but I think you were more
famous for bad reasons, not good reasons.
I remember that your classmates were talking about you when Pooyan started laughing, all the glasses start shaking.
That's right.
It's good to be remembered like that, though. I really like it.
Yeah, it was the same until maybe half through PhD, but then after
class, no laughing anymore.
Became difficult, no laughing.
Right. So I know some stuff about your background as an old friend, but I would like to ask you to give us some details about it. Share some stories from the past where you started it and what did you want to be growing?
I was born in 1980, and in my childhood I was fascinated by algorithms and robots. And I remember when I was a kid in school, I was in a small school and like we had a very small, tiny library, and there was only one robotics book. It was like not even a scientific book. It was a bunch of cool picture of robots, a little bit of text. And I remember I was fascinated by it, and whenever I got a chance, I was going to library and get if the book was available. But that was the only book, and rarely was available. I remember it was kind of I was fascinated by this concept of robots, where at the time it was 1990, probably before 1990, and like. Still, we know that we don't have robots in our home, but like we are getting there. But like at the time, I was fascinated by it, and later on, at the time, I remember I didn't know what is code, how we could write a code for a program, for a machine to do something. But later on, I think I was in like middle school when I got a chance to read in a magazine, like in a random magazine about computing. I found some written text in English, and I remember looking at it. It looked a bit of like a structured kind of English. So at the time, I knew how to at least read a little bit of English. And then, like reading in this magazine, I came to know there's something like a program or computer program, and there is something like a language in which you can write a program. And this language, it's maybe similar to English, which some people speak it. So it was very interesting. I remember. Obviously, I didn't know how to write such code, but looking at several examples, I was curious. Okay, maybe that's interesting. If we could, because I remember I was a little bit lazy, so essentially looking at it, and maybe we could write something that do a repetitive task for us. That would be good.
Right.
So, and then a few years later, I remember I asked my father to buy a computer for me, and eventually I got the chance to have a small Commodore 64, where I got the chance to write some programs. I was so happy. I remember I couldn't even go to sleep thinking about. Yeah, it was fascinating before college time, and and later on, we got the chance to go to college and learn about mathematics and computing and like these fascinating stuff. And like I started working as a software programmer after I got my undergrad, and I remember during when I was doing my master's, I was working at the same time full time.
Really?
Even though it was tough, but I remember even I couldn't go to like classes, most classes, and I missed couple of even final exam, because I was like crazy busy. But finally, I finished my master, and after a few years, then I thought maybe it's the time to continue research. So I quit, and then I got a scholarship from one of the research center in Ireland, and then moved there. I did my PhD there. I started.
Yeah, your PhD was on computing, or was it applied?
Yeah, it was on computer science. I was on autonomous system. Yeah, that was topic of my research during my PhD, where I still continue doing at least this is autonomous system, autonomous robots is one line of my research currently. But after finishing PhD, I moved to London at Imperial College. I did a postdoc there on big data analytics and machine learning. So during my PhD, mainly my PhD was about a little bit of mathematics, but mostly on like machine learning, but mostly on autonomous systems, how to make like learning system where they can learn from data and react in a real environment. But during my postdoc, I slightly switched to more theoretical machine learning, And I started doing research in transfer learning. I was fascinated at the time by this concept where, because it resonated with human learning, where, for example, when you learn something, you can learn something which is very close to this concept a lot easier, right? So, for example, when we were kids, like after sometimes going to play soccer, after learning soccer, obviously we could learn like volleyball a lot easier, or other sport a lot easier, because there are some similarity across these tasks, you could say. And then in 2016, I moved to the US. I went to CMU, University. I did my second postdoc there for 2 years between 2016 to 18. And then I moved to here, South Carolina, Columbia. And
What a journey. What a journey.
Yeah, it was.
So many cities and changes.
It was tough.
I cannot. I'm doing pretty tough things as well. It's fascinating. But you made it, and I think you did a great job.
Yeah, finally made it. we are still alive.
No, I'm quite fascinated by what you've achieved and how far did you go. Yeah, I really like that. I know it's fairly challenging moving from one place to another and doing tough stuff.
It is. It is a new learning, because you need to learn about new culture, maybe new language. A lot of new things. You obviously lose some friends when you found in one country, one city.
That's true.
And all of these are somehow costs that you pay.
I know.
But it is fascinating, because I found out learning about like different culture, different people. It's fascinating, and it helps a lot.
I know. You need to pay a very, very high price for it, but the fact that you like that adventure and you like to experience different life, different.
Yeah, I mean, like for me, like even until like 2 years ago, I was thinking I was really tired.
Really, of moving.
Like if you were talking with me even like 2 years ago, I looked a little bit of like tired, because it was tough.
Yeah, I know, it's very difficult. I don't think I've moved that much as you, but I really feel that the exhaustion and out of the kind of moving around and being in different places. Even you move to a quite new place, even finding a new street, the kind of supermarkets to buy stuff, or to find out what's the culture of that city, how I can find friends. Because your social security, it's gone as soon as you move to a new city, new environment. And this is very challenging. You're really pushing yourself out of your comfort zone every 3 to 4 years if you want to.
But now I do appreciate it. I cannot believe, after reading about like few articles in neuroscience talking about these experiences, exactly the way how you mentioned it, pushing you out of your comfort zone. That's where you want to be, because that's where you learn.
Yeah, that's true.
That's when you get a chance to learn and experience new things. And human only learns through experience, and that's the only thing. And exactly this is the way how like we teach robots or AI, because like experiencing by doing it, by exposing to a new environment, actually exposing to more difficult environment, it's the way how like AI robots learn. And that's fascinating. It's similar to human.
I guess you need to give us quite a good lecture about it. It's fairly interesting when it comes to robots, and I have a lot of questions about that as well.
Absolutely.
Right, that's great. I also read some news about you that you've got a great grant to do some research in AI. So if is it possible for you to give us kind of very short, clear cut, simple way of
Sure,
explaining what is this?
absolutely.
Right, was it 1.5
Absolutely.
million? Was it 1.5 million dollars or 1.5?
No, it was actually I mean, like this most recent grant that we got from National Science Foundation in the US. It was 1.2, and it is a project that has been started actually last fall, very recently, a few months ago, and it is in collaboration with two of my fantastic colleagues. Um, one of whom is Christian Costa, actually was my postdoc advisor at Carnegie Mellon University, who helped me a lot. Even like getting this current position that I have, University of South Carolina, he helped me a lot, and that was a fascinating thing, and still I'm fascinated by that. At some point in the career of like a person, you could make a difference, and that's fascinating. And that's why I love what I do.
I know how much you like it. So tell me, what is this research about, and why I think it's worth $1.2 million?
Right.
Because this sounds so cool, and I know how tough it is to get grants. Right? I know how tough it is.
It is tough, but at the end of the day, from like outside, because thanks to we have in our college some fantastic people writing reports about grants, etc. And from outside, it may perceive as fascinating thing or very imaginary thing, but it's not. Like the normal research that we do on daily basis is
and I know normal. How humble you are. You are quite humble.
No, not really.
Very humble.
I mean, I love this direction, and hopefully it make some impact. But I can explain a little bit what it is. It is actually intersection of two area which I like a lot. One of this area is called causal inference, which I learned very recently, actually after I started my position at University of South Carolina through a colleague in our department, Marco Valtorta, who has been one of those pioneers in this field, AI and also causal inference. And we started doing collaboration, and we co-advised the students, who is now a postdoc at Purdue, Muhammad Ali Javidian. This is a fascinating area that I was lucky to get to know, and now it is one of the main direction in my research group. Another field or area in this project is a computer system, especially highly configurable systems. For example, like modern computing system are all highly configurable, like from data analytics to like recommender system to even robots to drones. Many modern systems are highly configurable, and the number of configurations in these systems are more than the number of atoms in the universe. And when you select a configuration, this means that it might affect some aspect of the system. For example, it may increase or decrease the throughput of a system, meaning that the number of tasks that the system does per unit of time. It may also increase or decrease the energy consumption of the system, meaning that per unit of time or per number of tasks, how much energy it consumed. And we know that, like, some system, for example, if you have a drone, it wants to do some task for a specific mission, like it is connected to a battery, which has limited amount of energy. And we obviously don't want it runs out of a battery like on the fly, because we will lose it. Project is about how to, for example, understand performance behavior of such system,
right?
How to like find out about, for example, a potential cause of a bug inside the system, and how to automatically fix such bugs or optimize performance for such system. Partly, this project is very practical, because, as I mentioned, like many modern systems, even I didn't mention, I'm also a researcher at Google. Like at Google, like we have many systems, you know, that like of us use search engine when we do some search. Obviously, there might be some advertisement, so we have some a subsystem called advertisement system at Google, and all of these like are highly configurable, and like these systems across the stack, like at the software level, at the middle layer, and also at the hardware level. These are like there are a number of options. For example, let me give you an example. For example, when you have a hardware like this, you can even control like how fast the fan speed, spin, programmatically. This is one option. You can set it to any value that you want. And this is one option. And like, for example, it has a CPU in here. It has a chip where you can like control like the speed of the chip, right? The frequency of the chip, or even the frequency of the memory controller. All of it are highly configurable. Like you can tune it, you can tweak whatever amount you want, and these variables affect the performance of the system, the amount of energy that they consume, and this research hopefully is a step toward fixing some of the problem, because many even global incidents, like for example, you may have noticed sometimes that Facebook is not available, right? It happened like a couple of times in the past, even for like up to an hour. And all of these, after post-mortem analysis, find out that like the cause was a misconfiguration. And actually, this project is like how to solve such issues.
Wow. Yeah, I understand. It's very valuable.
I would like to also maybe talk about we have a project, a NASA project. Which these days I'm fascinated by.
Oh wow! Yeah, go for it.
This is one of the projects that, I mean, I feel so lucky that like we got the opportunity to be part of it, and I would love to talk about it. If
I love NASA. I love NASA.
So this is first of all like a very close collaboration with two teams out of NASA. One from JPL, which is led by Hari, and another team from NASA Ames, led by Michael Dallal, and actually our team. So basically, USC is leading it. But as I mentioned, it involved Carnegie Mellon University and University of Arkansas and New York. This is about the context of this project is about in the context of one of the future mission of NASA to outer space. So it is about the mission that they will have in around 10 years time to find a source of life in Europa Moon. Europa Moon actually is like the current best bet that humanity have to find any source of life, like beyond, beyond us, either intelligent life or non-intelligent life, based on the scientific exploration. But this is, Europa Moon is one of the moon of like Jupiter, is like very far away. And we know that it's even not Mars. Currently did not even send human to Mars, and still there are some rovers in Mars and helicopter, but this is for Europa Moon. And we know that like when we send a spacecraft in such a place, for any communication with the spacecraft, it takes like hours, right? Imagine that the rovers or a Spacelander in this case is doing a mission, in this case finding, for example, drilling some places, getting some soil, doing some analysis whether there is something living in this soil, or getting some analysis out of this material, and if, for example, the drill start there, or if the radiation goes up and the lander would not react to it, the mission would fail. And this type of mission like are $1 billion, right? So the aim of this project is to make, like enable this space lander to make some decisions intelligently by itself. Right. So basically we want to make it autonomous. Wow. So obviously it should also be able to, to collaborate with a human, for example, in NASA centers. And this also is fascinating, is related to human AI interaction. So collaboration between these two in order to do do some task which is not possible for either of them to do, right? And that's the key part. Right. And here, like the plan that we have is essentially like develop AI algorithms and AI systems in order to enable that. I don't want to go into very much detail, but essentially, I mentioned about like Europa Moon, but in Europa Moon, like there are some like a structure like this, and there are some like it's all ice, and that's why scientists believe that below the surface of this ice, like when there are some water, there is highly likely there are some living species might be there, right? Yeah. And that's why this within this icy world is one of the one of the most important or the most likely places that they find it, and that's why they have the mission to go there. Wow. And this is the how the Spacelander would look like. So basically, this lander would be sent there and would basically sit somewhere within this on this moon and start exploring and basically I will if needed I will go into this detail, but later on. But basically you can see that, for example, the lander, it has some arm in order to drill the surface, do some task. It has some capability, even like this, like the arm, it it has multiple different devices. Like it has also a scoop that scoop the soil and bring it back to another part of the lander which take care of the analysis, right? And these are, for example, this is the current version of the lander, or the version of lander which is for testing currently at JPL, that I mentioned is one of the team that we are working with, and my students and myself this summer most probably going to spend some time in to work. We're currently working remotely with this lander, and that's fascinating. So basically, they provide us some interface so we can run experiment remotely on this lander, right?
Oh, wow.
And that's how we make progress, right? And I emphasize on this project because this is, and that's why I'm so excited about it, because it's not one of those, project which is funded by NASA and like we do our own stuff in the lab, nothing to do with NASA. It's actually in very close collaboration with NASA, and I learned a lot since we started this project from this brilliant researcher NASA, because they have knowledge about space exploration, which I love, and also robotics. And also, like, we are able to test our technology that we develop, in collaboration with them on the real, robots or real lander that a version similar to this will travel, and hopefully, and that's our hope, because this is one of the aspect of the project make it super interesting, is that obviously NASA do a lot of testing, but some point the technology that we develop will travel to Europa Moon and be part of this system, which is why I'm kind of so excited about it. I mean, the main work that we do actually are done by my PhD students and postdoc, not myself, but at least I could be happy about like their progress, the work that they do, and the kind of technology that they develop in the lab. And thanks for your time, but I wanted to mention a little about it, because to share the excitement that I have, actually.
No, it's really exciting, actually.
And to connect with the like previous discussion, is that again, like the foundation, although it looks, maybe you have some robot, you have some fancy machine learning. At the end of the day, it's math, right? So like the theory, if we want to advance a state of the art, if we want to, go beyond what exists currently, which cannot do this, mission, we need to do math in order to develop something new, which maybe could do this mission, right? And that's why I'm excited.
Oh, that's really good. Thanks for sharing it. I really like that. And I love the fact that you start working in NASA. I think this is very cool and ambitious and adventurous, and super exciting. There you go. So it was a fantastic talk. I really enjoyed that. And I'm so glad to see how far you've been through and stuff that
it was not far.
It's great.
A lot less than what you guys did. But
it's a quite adventurous journey you've had, and I'm sure you'll see quite more of it, and more fascinating news and the stuff that is waiting for you. You also suggested that you want to kind of run or have a series of episodes by the AI.
I would love to. I would love to.
As well.
From time to time, we go over some, branches of mathematics. We at least brainstorm, we discuss. I would love to do it, because at least, for the audience of your fantastic podcast, might be useful, and I would love it to do it in discussion with you and maybe some colleagues of mine,
Yeah.
maybe like even some postdoc that started in my group, Sonam. She is also fantastic in mathematics. Actually, her background is very much similar to you, is control systems. And maybe or you invite her to,
Sure.
to join the
No, I would love
discussion.
to.
and I'm sure she has like deeper insight in mathematics, especially control theory and dynamical systems. And this is fascinating.
Yeah. No, I will love to, and I'm pretty much sure that I'll set up the whole series and we start recording, talking about it. And I think that would be a fascinating topics and episodes for people, because AI is a pretty hot topic in general these days, and I'm sure that that's future. Right, that's future.
That's right. That's right. I
You
cannot
like
wait.
it or not, it's future.
Yeah, that's
Now
right.
and future. So the sooner
I mean, it could be a future that might not be ideal. Maybe even that future may destroy us. But that future also could basically the only hope that humanity have to transition our legacy in after us, right? After humanity disappeared. Maybe that's the only hope that we have to, to descend that heritage beyond us.
Yeah, all right. That seems to be cool. There's a lot of kind of, hot discussion about and debates about that, what kind of future, the kind of life we will have, and how this AI kind of manipulate all the things and change our direction. But we definitely kind of talk about it, and that would be lovely to have you and your colleagues on the podcast.
Thanks a lot. Yeah, I'm so happy, and thanks for doing this. It is great. I cannot emphasize like how impactful your work is.
Thanks. I love that. I really enjoy that. I love talking about these sort of topics, and getting to know people, and get other people to listen.
It's fascinating.
Thank you. Thank you for listening to this episode. I hope you enjoyed it. I will have a series of episodes with Pooyan and his colleagues about applied maths, in particular artificial intelligence. And I will invite you to keep listening to it because it's getting really interesting. Don't forget to subscribe on platforms and continue supporting us.